Honestly, right?
Yeah. Okay, let's get started. So if you haven't picked up your midterm one, the pile is up here. If you have a homework 2 to turn in, there's a pile up here because Varun will be picking up that pile very soon. Okay, so if you have a homework 2, put it there. If you want to pick up your midterm 1, they're up here. So it was not fun grading these. I got like no work done whatsoever. So yeah, so statistics are up here. So these are the sorted numbers of total scores at the top, and then I took the liberty of recording the scores for each of the questions, not each sub question, but each large question, and I put the distribution here. Any questions purely about the distribution itself? Because I'm going to get into a bunch of other stuff. Yeah. How many exams were taken? How many exams were taken? There were 63 taken and 64 enrolled.
What?
Some guys just like,
yeah. Yep.
Overslept, man.
Yep, overslept for a night exam. I don't know.
Yeah, of course.
A very late sleeper. Okay. So regrades. So now everyone listens.
Yeah.
So regrades. If I on the test didn't transfer the number from the question to the front sheet correctly, like I didn't add up the points right, or if the front sheet's numbers are not added up right, although that's probably not possible because it did it in Excel, and I doubt Excel will be wrong. If I just made a logistical error like that, during the break or whenever, just bring the test to me and I'll fix it. There's no issue there. So purely logistical, I make mistakes, just bring it to me, there's no problem with that. Or if you want to verify that I recorded the right grade, just ask me. So if you are wanting more points, that's a different issue. So if you think, oh, Ryan graded this question incorrectly, then here's what you do. You go to the front sheet of your test, you write a paragraph or a few sentences explaining which question I should look at again and the reasons why I should look at it again. So like if the question said to convert an NFA to a DFA and you believe that you actually applied the method correctly, then, and I didn't give you full points or whatever, or the justification for my taking off points was not correct, then write a reason why you should get those points again on the front page along with the question. And what will happen is I will go through the entire test again and regrade it from top to bottom. So whatever happens, the new grade, whatever the result is, will be final after I look through the entire test again because I don't know if I graded the other questions wrong. It's to prevent any biases that may occur. Okay? So the grade may go down, that grade will be final. If the grade is exactly the same, that grade is final. If it goes up, great, it's final also. Okay? But so usually the lowering never happens. I don't think it's ever happened for me, but it's just, I'm telling you it could happen. I may have missed something else that I should have noticed earlier. Okay? So if you want to regrade, write the reasons for it on the front page and which questions, and then bring it up to me sometime today, on Wednesday or Thursday. Okay? Sound fair? Any questions purely just about grading? We'll go through the test itself. Yeah.
So, no cutoffs?
I don't know what cutoff.
Like, no lowering bars? No?
So you're asking, am I going to curve the test?
Yeah. Because it's 209 out of 250 is the best.
Curving should be illegal.
But lowering the bar.
No. Here's the thing. What does curving mean? If you had to give me a definition for curving, what is the definition of curving? Is actually to your disadvantage. Because here's what happens. Find the middle of the distribution. That automatically is a B minus C plus borderline, no matter where it is. If it's a 95%, that's a B minus. If it's a 23%, that is a B minus, C plus. Do you think that's fair?
No.
No. Here's what I look at. I look at this grade distribution, and I try to find where natural cutoffs are. So what I would probably say here, this is just a rough approximation, but so this is not written into stone, so don't quote me on this. Don't write a review on Rate My Professor saying, oh, Ryan said that this is an A, but I didn't get an A. WTF. So what I would say is if you got above a 140, you're in the A range. If you got above a 125, you're in the B range. If you got above 100, you're in the C range, and then D and E below that. That sound fair?
Yeah.
So I look for natural breaks in the distribution to say, is this an A performance relative to the rest of the class? And considering the difficulty and the length of the test. So I'm not just a black box where I just say, oh, I transfer these numbers into letters. I could do that, but that's not in the best interest and it's not humanistic, okay? I try to look at this from a humanistic point of view. This is the longest midterm test I've ever given, okay?
Yeah.
It was a long test, not temporally long, but also the number of questions. So, yeah, that's what I would consider cutoffs. But remember, the final also replaces the midterm, so I can't really give an approximation like this because the entire distribution may change. Yeah.
You mentioned the final versus midterm. Would it be, let's say I did better on my final than both of my midterms?
Yeah, it would replace both. So it would do the best possible thing. Yeah.
If you got 100, you'd be-
So if you got 100% on the final, you can get 100% in the class.
Whoa.
Okay. So this is one of my philosophies is everyone deserves a second chance. So here's something that you should take away. We're going to go through the test, but here's something you should take away. It's okay to lose points once. That's okay. We're human. We miss points sometimes. But it's a bad idea to miss points twice. Okay? Does that sound fair? Yeah.
So the final, if it's better, like if you place two tests, is it better? Like that's
I just answered that.
Yes, it does.
It replaces both if you did better on both. It replaces one if you did better on just one. It does the right thing. Yeah. They were just posted, and I'm going to go through it. Other questions? Yeah.
Will our final be similar length to this test, and will our other midterm?
It's literally the same length.
Like same question. over.
The same temporally. Probably the same number, but obviously the content will be different. But same length, same number probably. Yeah.
Are you gonna record the sheets today to make sure where you go through the?
I'm recording right now.
Wait, oh yeah. So is second exam going to post it on this one?
You trailed off.
Second exam also on this one.
Yeah, the second exam will have the same format. Not same material, obviously, but same format. Other questions before we go through the test? Okay, so let's go through the test. This is just a sample. These are not the solutions. Done, done, done. So each of these questions can have infinitely many possible correct answers. So I'm not just a robot that just goes through and says, oh, this is correct, this is not correct, it matches exactly or it doesn't match exactly. I look at it and I try to read and understand what you're saying. And of course, I could have made a mistake. That's why you can always have your test regraded. But I tried to be as forgiving as I can be. Okay, so let's scroll somehow. There we go. So first question. If you look at the distribution, let's actually go back through the distribution before we go through the solutions. Look at the distribution for Q1. It's actually really, really good, and I was very happy about how well everyone did on Q1. And also for Q2, many people did very well on Q2. For Q3 and Q4, notice that most people didn't do well on this question. there weren't really many high scores on Q3 and Q4. So take this into account. Q3 and Q4 were hard for everyone. So you should understand how to approach questions like that, but just understand that this really was hard for everyone. If you scored low overall, this was hard for people at the top of the distribution too. But look at Q5. A lot of people didn't do well, but there were some really high scored questions. Some people got really high on that question. So which question do you think, if you didn't do well, should you focus on of the 5? Q5, right? Because the average was low, but there are some that are still high. Q3 and Q4, you should pay attention to those, but the distribution was also low. If you scored low on Q1 and Q2, you should focus on those also because the distribution is high up also. Just something to keep in mind. Okay, so let's go through the test. Question 1A, where the string, all the strings that contain 1, this was relatively straightforward. Most people got this one. And if there are any questions, just stop me in the middle. Yeah, so this one is pretty easy. If you see a 1, no matter what happens afterward, you accept. For B, you just have, if you start with a 1, you should never accept after that because the L2, the language is it starts with a 0 and something else. So if it starts with a 1, it can't be in that language, which is why the transition to R3 and then it just loops on everything. If you have a 0, then the other qualification is you have to have length at least 2, which means it doesn't matter what appears as the second character, but you got to have a second character. So you need the 0, 1 to go to R2, and it doesn't matter what you read after that. C, practically a very few number of people overall applied the product construction. Some people just did it directly. I didn't say you had to use the product construction, so that's fine. But I'm doing the product construction here. I noticed some states that were unreachable. If you delete these 4 states, you arrive at if you just did it directly. But either method was absolutely okay. But yeah, product construction. And then the only final state is the one state that is final in both of them because we're making a DFA for the intersection, not the union. Okay. D, a lot of people missed. So take a note of these things. I haven't recorded these sub-level questions, like how many points each person scored, but I remember which questions people had a tough time on. D was one of them. So pay attention for D. So yeah, so this was actually either in a sample homework or in the sample, I think in the sample midterm that I gave. So this appeared as a question there. So the idea here is that you can rephrase multiple of 3 as having remainder 0 when you divide by 3. So if you take the number 6 and you divide it by 3, it divides evenly, so it has remainder 0. If you divide 7 by 3, you get 2 with remainder 1. And then 8, you get remainder 2. So there are 3 possible remainders, 0, 1, and 2. And then if you read a 0, that corresponds to multiplying the number by 2. And in fact, we did this in office hours. If you read a 1, that corresponds to multiplying the number by 2 and then adding 1. And then it's just figuring out where you go from each of the 3 possible remainders that you currently have. If you have remainder 0, then multiplying the number by 2, this number is still divisible by 3. And then adding 1, you just go around the circle 1 state further ahead. Okay, so yeah, so that's how you make that machine. Question E, I think I asked in class for you to think about and to try yourself. The number of 0, 1, and 1, 0 substrings is the same. So if you have a 0, 1 somewhere, and let's suppose that this string is in this language, and it has a 0, 1 somewhere, what must you see at some point? If it has the same number of 0 1s and 1 zeros. It starts with 0 1 and at some point I must see a 1 0. Well, could a string that starts and ends differently be in this language? Well, if it starts and ends differently, either the number 0 1s overpowers the number of 1 zeros, or the other way around, because they start and end differently. So in fact, this language is the same thing as saying starts and ends with the same character. So here, the empty string, it starts with the ends of the same character, namely the none that it has. If it starts with 0, then it must end with 0. If it starts with 1, it must end with 1. And the 4 states on the right handle when you end with a 0 or end with a 1. And then a lot of people got F, which is good. Contains 1 0 as a substring. This doesn't say ends with 1 0 or starts with 1 0 or is just 1 0. This has 1 0 as a substring, so anything can appear before and after, which is why we have non-determinism here. In fact, a lot of people didn't even make an NFA here; they just made a DFA, which is fine. But it's just a lot easier to make an NFA for this. Whenever you have a substring question, NFAs are a lot easier. Okay, any questions on question 1? About making NFAs? Yeah.
So why do we need the 0, 1 going into Q0 and Q2?
Because anything can appear before the 1 0. So I'm exploiting non-determinism here. So read anything, and then when I choose, I go the 1 0 route. And then, so the non-determinism helps here. You can convert this to a DFA and it would get the right thing, but it's just to handle anything that can appear before the 1 0.
So I'm just thinking, if you didn't have it, it would still...
So if we remove the 0 1 on Q0, this NFA would be the language where it starts with 1 0. Because the only thing that you could do is do that 1 0 path.
But it can be, right? It's in substance.
Yeah, but that's just a subset of L5 here. But I want L5. So what if I had 0 0 0 0 0 0 1 0 substring? So it can appear anywhere in the string, which is why non-determinism is easy here. A lot of people made a DFA, which is fine, but NFA is easy. Yeah.
What if it's a 0 1 1 0?
Yeah, so what you would do there is you would do the 0 on Q0, 1 on Q0, 1, and 0. If there's a choice, if there's one way for me to accept, I will make that choice. That's what non-determinism means. Okay? Any questions about Q1 overall?
So you don't need a 1 on the Q.
I could put a 1 transition on Q1, but it'll actually not matter. Because I could have just stayed in Q0 anyway. If I left those 2 in. But as I said, a lot of people did a DFA, which is fine. Other questions? Okay, let's go on to Q2. So this was done not as well as Q1, but still well overall. For part A, some people did not apply the method. So it says using the methods described in class. If you don't use the methods in class, what do you think I'm going to do? Well, not just take points. Bang my head against the wall. No. No. Yeah, I'm going to take points away. So one thing to keep in mind is when you're taking a test, although you should know this at this point, when you're taking a test, read the directions. The directions are there to help, okay? If it says do it this way, do it that way, okay? So using the methods in class. So you had to make a small NFA for A and B, and then union them together, and then concatenate that NFA with a small NFA for just A, and then do the star on the whole thing. So in fact, look at the naming order of the states that I have. So I have 0 and 1 for the A part, 2, 3, 4, 5, 6, and 7. So there's an order to it, and how I do this actually. Any questions on part A? Yeah.
Can you go from is that Q1? Can you go from Q1 to Q7 with an epsilon transition or no? Like Q1 and Q3?
So Q1's after the A transition at the top. Well, why would I go to Q7?
That's what I did.
Well, remember the stars on the outside of the A union B A stuff.
Okay.
Yeah, so it's on the outside. So I have to process the inner layers first before I do the star on the outside.
I was going to say that the Q1 and Q3 like branch off into different epsilon paths.
Yeah, so that doesn't work because I'm concatenating that NFA with the NFA for just A. So I have to go from the two final states here, epsilon, to the single start state for this other NFA. Remember, we're concatenating NFAs here. You're right. If I expanded this and I gave you AA union BA, then you're right, you can do it that way. Where you have like these two separate paths, and then the two epsilon back to the original start state, the new start state, but that wasn't given here. So you have to do the single NFA here and then epsilon from both final states to that one. Oh, yeah.
Just to clarify, it seems like you're specifying that because the way that you described it would be following the method described in class, the way you described.
Yes.
But it's not exactly that. Or never mind, no.
I'm not sure what your question is.
It's not really that important.
Okay. We can talk offline.
Sure.
Yeah.
So from Q1 for A, we're taking epsilon. Is that going to be like all the way to Q0?
So from where to where?
From Q1.
Yeah.
We're taking like the set,
The epsilon transition, yeah.
for A. So is it going to be Q1 to Q5? That's epsilon.
Yep.
Then reading A can go.
From where to where? Reading A from where?
So if we have the set for like reading A for Q1.
Why would I have that? Well, that's not the method, though. The method is making a small NFA for just the A, and then concatenating from the final states of the conglomerate NFA, the two final states to that start state. So it's agnostic to the structure. It's just going from the final states of one to the start state of the other. Other questions about A? We have a lot more to get to. Okay, let's go to B. So B is just converting from a NFA to a DFA. Some people minimize the DFA. You could technically do that, but that's not the method described in class. If you minimize the DFA and think you should have gotten points, you can make a case for that. Because the problem is that it's not the method described in class, but if you can make a case for it, then I'll consider it. But here is just considering epsilon closure. So the start state is, well, I start in 7, but I can also go to 4, 0, and 2. So that's why I called the start state of my DFA 0, 2, 4, 7. I just listed them in numeric order. And then I figured out, okay, if I go on A from any of these states, the only one that actually matters is the Q0 one. So if I go on A there, I go to Q1, but then I consider epsilon closure from there, which only gets me down to Q5. So the state I go to is 1, 5. Okay? If I apply A from 1, 5, well, I can go to 6, 7, 4, 2, 0. So that's why I have the state 0, 2, 4, 6, 7. Then I can do A there. If I did B instead, well, the only state that mattered there was Q2, which would take me to 3 and 5, which would put me at a state 3, 5. And then I can make the states as need be. If I'm in 0, 2, 4, 7 or 0, 2, 4, 6, 7, and I read a B, none of them have, no, never mind, sorry. If I'm in 3, 5 or 1, 5, then neither of those states have anything that goes out on B. So I go to the dead state, which, that shouldn't be 0, 1 down there. That should be A, B. Sorry for that. I'll fix that. But yeah, we have a dead state down there. And if you actually look at how you actually get there, it corresponds to either the B being the having odd index if you index from 0, or you have a BB somewhere, which is the same thing. Any questions on part B? Okay. C, a lot of people missed this or just left it completely blank. If you leave a question blank, how many points am I going to give you? 0. Non-zero. No, I'm going to give you 0. So put something down. If you have no idea how to start, put down your ideas of how you would go. First, I would set up a GNFA and then I'll rip states. That's worth something because it shows that you know something. If you have no idea how to start, just tell me your ideas, okay? A lot of people, surprisingly, didn't do the first step of the GNFA ripping process, which is to put the new start state on the front and going to a single final state on the end. So you have to do this, no matter what the original NFA was, or DFA. So that's what I did here. We had 2 final states, so the 0247 and the other one, they epsilon to the new final state. And then if you notice, well, the empty set state has nothing coming out of it going somewhere else. So I'm just actually free to delete that state and the police won't be after me. So I just omitted it because it doesn't matter. It doesn't change anything else. If we rip 02467, I'll let you check the details. I'm pretty sure I got that right. Then I'll get this GNFA, then remove one more state, one more state, one more state. And then I renamed the regexes along the way, and then I get this regex at the end. By the way, if you rip states in a different order, will you get this exact regex? No, but will it still be correct if you rip states out correctly? Yeah, so it doesn't matter what order you rip states out in, but all that matters is that you rip correctly, okay? I just ripped it in this order because it looked easy, but your mileage may vary, obviously. Any questions on part C? Okay, question 3. Here's where people missed a lot of points.
It was very hard.
I'm actually surprised on part A. Part A should have been the easiest one. When people write, this is true because of closure under union, what do you think I'm thinking? Yeah, where's the union here? What are the operations being applied here? Intersection and complement. So if you write intersection under complement and closure under intersection, you're done. Okay? So you just have to write those 2 things. And true, obviously. But for B, some people wrote that this is equal to sigma star. So I don't know about you, but I don't think there are infinitely many strings stored on web pages. How many web pages are there? A lot, but finite. How much information is on each web page? Finite. So what is the number of strings stored on web pages in total? A finite number. So what do we know about finite languages that we talked about in class? They're all regular. So if you just wrote all finite languages are regular and said true, that's it. Okay? If you said that this is an infinite language, I don't know what version of the internet you're using, but you need to tell me immediately. Okay. C, a lot of people said that this is concatenation, and that I had a very sad face. Is this concatenation? What does concatenation mean? And I think I went over this in class. You pick a string from the language, and then you pick another string from the language, maybe the same, maybe different, and then concatenate them together. What does the right side of the equal sign say to do? Pick the same string twice. Is that the same thing as picking anything and then independently another string? That's not the same thing. So some people saw this and said, well, AA is just the set of even strings where each, even length strings where each piece comes from A. So like take, for example, A equals 0, 1 star, so all binary strings. So AA then is just a set of all binary even length strings, but the WW one, that can't possibly contain 0, 1 because it's not the same string twice. So that would be an example. So I did an example a different direction where I said we have closure under concatenation, so AA is regular, but WW for sigma star is not regular. So I think I mentioned that in class. So that would be proof that they're not the same, always. Okay, any questions on C? So when you see something like this, think, what does concatenation actually mean? Okay? Concatenation means picking a string, but not necessarily the same string twice. Oh, and here's another thing. If you say something is false and give a long explanation for what regularity means and what concatenation means, what were you supposed to do? Give an example. That's what the question says. Give a single counterexample. Don't give a long paragraph wasting your time. Yeah.
What would your tips be for generating a counterexample?
So like for C, for example?
Yeah.
Well, if you notice that it's not the same string twice, then you can just make a small example like A equals just the two strings 0, 1. Not star, just 0, 1. Then AA will have 0, 0, 0, 1, 1, 0, 1, 1. But the WW one will just be 0, 0, 1, 1. They're not the same, and you're done. You can do sigma star, but it depends on the example. But a small example is fine. Yeah, any example is fine. Yeah.
Wait, this might sound stupid, but can you say the language in English?
Which one?
Like the C. So
It's
if
C.
you pick any string from A.
Yeah.
Put
So
it together, it's the same.
yeah. So here it says pick any string in A, then concatenate it with itself. Put it on the right side. That's the right side. It's the same string twice. So pick any binary string you like. Then the WW language is just that string with itself and no other string. Whereas the AA one on the left says pick any binary string and any binary string not necessarily the same, and then put them together.
So it's like A, B, basically, because it's a different.
Yeah. So you can think of it as WX, W concatenated with X, where W and X both come from A. So there's no dependence on the W and the X part. Any other questions on C? Okay, D and E I'm going to do at the same time. The vast majority of people got like 1 point on this question. So here's the thing. If the question, so what is this question really saying? Or both of these really? It says, are the regular languages closed under concatenation? Oh, and then E is, are they closed under star? If you write regular language, this is true because regular languages are closed under concatenation, that's a circular argument. Because the question says, prove that this is true or show a counterexample, and you said true because it is true. So you see why that's a problem? And then you may say, oh, well, why don't you have that problem for A, where you said, oh, all you need to say is closure under intersection and complement. Why are these two different? Because this is not asking specifically about intersection. It's asking about the composition of two operations. If it's asking about a certain thing, you can't just say, oh, we showed that in class. But if it's two things, multiple things, and it's not about each of those specific things, then you could just say, yeah, it's just closure under complement and intersection. But if it's about that specific thing, you can't just say, oh, we have closure under concatenation. It's kind of circular. The right way to do it is to do a diagram, the ones that we did. So if we have a DFA for A and a DFA for B, or NFA, or whatever, then concatenate them this way by going the original final states to the new start one. What's another way you can prove this? What if we had a regex for A and a regex for B? What do we do with the regexes? Stick them together. That's a lot easier. If you had one for, if you wanted one for A for part E, then just parentheses with a star on top, and then you're done. And then now you have a regex for A star. Okay? Yeah.
But in one of the lectures, you mentioned that if we prove something in the class, you don't need to re-prove it again
But
in the exam.
Yeah, but the question's asking you to show that this is true. That specific thing. You can't just cite the result in class. Oh, we did this in class. It's asking you, look at the question. It says, give brief reasoning as to why. So if it's asking you to show that it's closed under concatenation, then you need to show that it's closed under concatenation. But what I said in class is, if it's not about that specific thing, then you can use it, which is like what part A is. Okay, you see the difference between the two? So don't really worry about D and E other than not doing a circular reasoning, because most people miss these two for that reason. Any questions on D and E? Okay, we need more. So F, only a few people got this. So the reasoning here is, I didn't want you to go into too much detail. This is actually more detail than you need. But the idea is, well, star is picking some number of strings from A and then putting them all together. The double star one is just doing that process twice. But I could have just done that earlier anyway with the original star. So in fact, they're the same. There's more detail there, but that's the essential idea. For G, so a lot of people missed this one too. Well, actually, most people missed all 5 of these on the back. So F through J or whatever it is. The problem here is, if you say that this is product construction, it's not. So if A and B are regular, then the A intersect B is regular. That's true, because that's product construction. The problem is, this is the converse of that statement. If the intersection is regular, it's not necessarily the case that both pieces are regular. So an example would be, take A to be empty and B any non-regular language at all. Well, the intersection is the empty set, because the intersection with the empty set is the empty set. And the empty set is regular, so therefore this is not true, that A and B are both regular. Okay? Yeah, so that was G. H, this is understanding closure under complement for regular. So if L bar wasn't a non-regular language, it must be regular. If it's not non-regular, it is regular. So so that L bar is regular, then closure under complement for regular languages tells us that L itself is regular. But that's a contradiction if we assume that it was non-regular. So it's just that regular languages are closed under complement. Non-regular languages are also closed under complement, because if it went out to the regular languages, then it would stay over here in the regular languages, because they're closed under complement. So they must be closed under complement too. So a lot of people got H, that was good. I and J, a lot of people missed. So yeah, so this is just getting you to think about, well, what if we talked about this for non-regular languages? Instead of just regular, what if we did this over here? So, so if we take A to be any non-regular language and B to be the complement of that language, then by the part H, then B is also non-regular because it's closer to complement, but their intersection is nothing because there's no string that's in A and in A bar simultaneously. But empty set is regular, so it can't be in the set of non-regular languages. And the same idea with J. If you have a non-regular language like primes or perfect squares over an alphabet like 1 or 0, doesn't matter, and it contains the string 0 or 1 in it, the single length string, then with star, you can make any length string you want by just picking that single length string as many times as you want. So you can get the set 1 star from that, which is regular. Okay, so I admit these two are a little difficult, but it's to get you to think about using these operations in a different context. Okay, any questions about question 2 in general? 3, I guess. Yeah.
This question, can we give an example for I as like if we have two non-regular languages, they won't make a regular language. Is that considered as a counterexample?
Oh, I'm not sure what you mean. Well, here's an counterexample. If I take any non-regular language and its complement, both of them are non-regular, but their intersection's empty. Because there's no string in both of them. Other questions about 3? Okay, let's go on to 4. So a lot of people miss these ones too. So what I should recommend you to do is to read the questions. I said that before, but read the question. What does it say? It says, do regular grammars generate the same languages that regular grammars do? Okay? So does that mean taking a regular grammar, flipping the one type of rule backwards, and show that they're not the same language? Is that enough? Look at what it says. Do regular grammars generate the same languages that regular grammars do? What are the languages that regular grammars generate? Regular languages. So this is asking, do regular grammars have the regular languages? Are those the set of languages? Showing that one example and then flipping the right-hand side and showing that those two languages are not the same doesn't prove anything about this. It shows you that if you just did this operation, you won't get the same language, but it's regular in both cases. That's what this question's asking. Okay? So think about what this question's asking. It says, for this BA rule, you're just flipping the one rule around backwards. So what happens is, well, if you're generating terminals on one side with the regular grammar, but now you have a regular grammar, you're generating them backwards. Okay? So instead of generating them one way, you're now generating them the other way. So they're not the same, it's not the exact same language, but it's the same set of languages. And I wrote that on many of your submissions. So what we're really asking is, if you have a regular language and you flip all the strings backwards in it, is that still a regular language? So that's what we're really asking. So the one example I gave here is, if you take an NFA and flip all the transitions backwards, then you're essentially there. You're not quite there, but you're almost there. You'll get an NFA pretty much for the reversal language. So if you flip all the strings around, you just go the backwards way through the NFA. There's a little work to do, but it's essentially that. So then we have an NFA for the reversal language, and then we're done. Another way you can prove this is by looking at a regex for the language, and then just looking at each of the 6 types of rules, and then flipping the right-hand side to B backwards. And then you're done, pretty much. Any questions on part A? Yeah.
So is like the reversal like an operation like separate from the regular operations that we should also just know?
Yeah. Not that you should just know. It's just an operation. After this, you probably should know it, but we're not really going to encounter this. We might encounter this, but it's not a huge deal. Who had a question? Any other questions on A? Okay, part B. A lot of people on part B wrote false and then a giant paragraph. What do you think you should do if you write false on a question? Write a counterexample. I bolded it for a reason. Okay? Should I put it in caps too in a bigger font? I don't mean to be harsh. I mean this in the most generous way. What should I do to make this more clear?
I think sometimes it's just hard to think of a counterexample, so people fill it in.
Yeah.
Or then just say, I can't think of a counterexample, but here's my reasoning. Be communicative. Be a human. A human is reading this. Although you may not consider me a human, but I am in fact a human, believe it or not. So I have to evaluate you somehow. So if you write a long paragraph with no counterexample, I don't have anything to judge off of that other than what you wrote. And it's often not a good thing. Okay? Yeah.
So you're saying, so if I write, how was your day going, basically, will you give me a point?
Possibly. Well, considering how arduous this was, probably a few. Yeah.
So theoretically, in the case that we can't think of a counterexample, saying I can't think of a counterexample, and then your logic is better than just writing your logic. It would be better because you're saying, oh, I'm trying to think of a counterexample, but I can't think of one because reasons. But that's a little harder on this one because we actually went over this example in class, this grammar itself. The key I wanted you to see is that when we have a linear grammar, we have any number of terminals on the right side, but as long as we have one variable at most, we're okay. Well, if you look at this and you say, do they generate the same languages as regular grammars? You have to think, well, could I make an example, or did we come up with an example of a linear grammar that is non-regular? And look at the point allocation. The first one was 20 points, and this one was 10. So notice that there's a pattern here. I try to allocate the right amount of thinking for each of the sub-questions, okay? So for 10 points, you should think half as much as the part A and C part, okay? I try to be logical here as much as I can. Okay, any questions about this? Part C. So only 2 or 3 people got this.
Wow.
So the idea here is, well, we can start anywhere in the start states, but think about, say, the union construction for NFAs. What did we do? We made a new start state, epsiloned our way to the original start states. So this is essentially a generalized version of that, where we can start in any of these states that I give you. So why don't we just do that idea, but epsilon our way to all of those states? Well, think about what happens. If in fact, they're equivalent, because if the original NFA accepted, well, we can just find a path through one of the ways in. And in fact, this will get us exactly what we want, because this is in fact an NFA. Because if I just take the original NFA and whatever states I need to be the start states and just epsilon to each one of them, I'm in fact simulating the multi-start FA. Okay? Any questions on C? Let's get through the test and then we'll break. Question 5. Okay, so one of the biggest things, so the very first part is fine. A lot of people got that. Assume L is regular, there exists a P for L. Fine. What was one of the things I told you most students missed? Choosing a string with what properties? Longer than P in the language. A lot of people, in fact, the majority of people, and I would even say the vast majority, did not actually do that. So if we don't pick a string that's long enough or is in the language, can we say anything? No. So in fact, I should just stop reading at that point and give a grade based off what you did in those two first parts. So because the rest of it is meaningless. But I try to look and see, do you understand what you're trying to do? But if you're really trying to prove this, this won't work. Because if you pick a string not long enough, you can't say anything. And if it's not in the language, you can't say anything. So a lot of people picked A to the P, B to the P, C to the P. Is that in this language? No, why not? Yes, someone has to win by majority. If everyone tied, did someone win by majority? And there are 3 people. No. Okay? So, yeah, you can't have that. So, I picked an example here. There are many, many other ways you can do this. So this is not the only way. But the way I did it was, I picked a string where I had exactly the right amount of votes to win for A in this case. So the string's length was 4p, and A had 2p or half the votes. So the idea was, well, if I add more A's into the string, well, the string length gets longer, but the number of A's also goes up at the same time. So will I ever leave the language? No, because the fraction of A's compared to the string is going to go up, which means A is going to win more, win more by a landslide. So what if we took A's away? Well, the string length goes down, but also the number of A's goes down. But the number of B's and C's don't go down either. They don't go down. So what you do here is you say, well, I don't know how many A's were removed, but if we took the absolute most number of A's possible, which is P, well, then we end in a tie, which is not in the language. Well, in any other case, well, if we looked at the number of votes that A got compared to the length of the string and figured out whether that was at least 50%, that actually has no solution whatsoever. There is a solution when beta is equal to 0, but is beta ever equal to 0? More people should be emphatic here. Is beta equal to 0? No, it's always at least 1. So in fact, it always leaves the language here when I choose I equal to 0. Okay, and then I didn't do all of part B, but it's almost identical in terms of structure. So more people got this one closer. They picked the right string, maybe accidentally by picking A to the P, B to the P, C to the P. That is in this language, but it's just if you picked I equal 2, then I may only add 1 A into the string, but then an almost draw also occurs. If I add only 1 A, then the number of A's is P plus 1, but the number of B's and C's is still P. So an almost draw still occurs. So if you choose I equal 3, then you do leave the language then. So you have to think a little bit there. Okay, any questions about question 5? I know you guys want to get through. Question 6A and B, I'm just going to briefly go over these because very few people actually attempted these.
We didn't have time.
Yeah. So what was the first thing I said before the test? Don't write too much. I'm not expecting a lot of writing. Okay? So what are you going to not do for the second test and the final? Write a lot. Okay? Don't write a lot. I'm not expecting a lot. I don't want to read a lot. Actually, I do, but it's a lot of work, okay? So don't write too much. Part A. Well, what does this really say? If you look at the English description at the end, it says we can pump any p-length substring. So if you pick a substring of length exactly p, then we can pump only in that part. So if you think about it, what does the proof of the pumping lemma say? Well, if we had at least p, if we had p states, and we've looked at a string of length p, then there's a repetition that occurs. So if we look at a p-length substring, ignore the rest of the string, just this part right here, then if you look at the computation that occurs among those p characters, some state repeats. And then that's all you need. Because then you can just go around that loop as many times as you want. For B, this was a little more involved, but this was from the sample test. Okay? So it's, well, based on it, I guess. So the idea here is based on the pumping lemma. The idea is if there's a loop somewhere that goes to a final state and you can reach the loop, then there are infinitely many strings because you can just go around that loop as many times as you want, getting more strings and then go into the final state. So if it's finite, the language of the DFA, then the longest possible string that you could accept is of length p minus 1. Because if you accept a string of length at least p, then there was a loop somewhere, but I can go around that loop as many times as I want. So what you do is you make a DFA for the original language and having length at least p, which is possible to do as long as you know what p is. And then you just ask, is there anything in that language that's in the original one and having length at least p? If there's anything, great, the language is infinite. If there's nothing in it, then the language is finite. So you just ask, in this product DFA, is there any way to accept anything? So you can just do a search on the DFA, see if you accept anything. Okay, any questions on the test overall? I know we all want a break. Okay, let's take a break.